Hi there! Let's briefly give an intro to Quora. So it's a US company with a question answering website where millions of internet users are asking questions and usually seeking for an answer. And unlike Google, where until a few years ago the search engine works best by typing the keywords of one intent, on Quora the questions have always been in a more human-like language. You basically speak your mind and formulate the questions as best works for you. Now, given the large number of questions on the platform, an important product principle for Quora is the allocation of a single page for each semantically distinct query. In other words, when the intent of multiple questions is the same, users should reach the same canonical page. This valuable principle makes knowledge sharing and communication in general much more efficient. The company also released an interesting dataset for data scientists with the purpose to share their challenging goal in the domain of natural language processing. The idea is to train and test models for semantic equivalence and build an automated system that detects pairs corresponding to the same intent. This is how the pair of questions look like. And this set of data provided in the English language is publicly available and consists of over 400,000 pairs. We apply BERT, the bidirectional transformer, on semantic similarity and show how it is a great candidate for paraphrase-related tasks. We do this by feeding the pair of questions as an input of two sentences and then fine-tune the model for a binary classification objective. The task of QQP is actually one of which the BERT model in the original paper has been evaluated on, and it is part of the GLUE benchmark on which nowadays state-of-the-art NLP models are tested and compared. I did set up and wrote a series of collab notebooks to fine-tune the BERT model on the QQP task, and in this first notebook presented with structured content, I worked through a few key points covering both the dataset and the tokenizer. There is a section where we parse the training set and plot the length of the input sequences, and based on this distribution, we can then decide to truncate the sequences to a max length in order to get a simpler version for the dataset. We employ the Hugging Face library and its methods to load the BERT tokenizer, which is based on the word piece tokenization, consisting of letters, words, and subwords. And the library itself comes with a very generous number of variations. Only for BERT tokenizer, we have Chinese, German, cased and uncased, BERT base and BERT large. And for instance, we show how the variants of BERT base and BERT large they share the same vocabulary. We use the method getVocabulary of the specific tokenizer to do this. From the Hugging Face library, it did present the relevant classes for tokenization, showing clearly the different helpful methods to work with. There are indeed a couple of methods to encode the input, and several ways to convert the input IDs into tokens or string format. We then encode the Quora dataset through the tokenizer. In here we adopt the method encode plus with the appropriate input arguments while writing the necessary commented code, and then we save what's needed for later use. The Hugging Face framework provides helpful and comprehensive interfaces to apply BERT models to the major NLP tasks. Here are some names given to a few of these. These variations all share the same pre-trained parameters, so same weights, but depending on the classification objective, they differ in the input and output configuration of the specific class instance. As I left explained in this notebook, in our case we applied BERT for sequence classification. And we use Adam Optimizer with weight decay, hence the name AdamW by the way. And we apply a learning rate schedule with a warm-up over the first 10,000 steps, followed by a linear decay. We refer to the original paper to set most of the configuration hyperparameters during the fine-tuning. And during training, depending on the GPU given to us, the time taken might change. With the Tesla P100, it would take about 3 hours to fine-tune the on 3 epochs. This GPU, for instance, performs with 87, 88 sequences per second. Consider each sequence of 512 tokens, given we are employing the pre-trained model of BERT. The class distribution in Quora question pairs is unbalanced. 63% are negative examples, which means they are not duplicate of each other, and this makes only 37% in the dataset a duplicate pair of questions. Adopting the model fine-tuned in the previous notebook, we perform an evaluation of the labeled set with 40,000 pairs and compute accuracy and F1 score. Over time, I realized this process will take around 9 minutes and 30 seconds on the Tesla K80 and only 2 minutes and 30 seconds on the P100. And in order to get a better sense of these metric values, we perform a series of analyses with confusion metrics, with absolute numbers and percentages. Given the dataset unbalance, based on this class distribution, we apply a simple strategy to weight the cross-entropy function, and it is worth noticing that BERT with its fine-tuned QQP model shows an interesting robustness to this matter. It comes in handy sometimes to run the model and experiment with several syntactic variations of the same question. For this purpose, there is a code session which performs single predictions. You might think to rephrase the sentences or replace individual words with synonyms. Or you can leave one sentence unaltered and run the said code with permutations on the verbs, nouns, adjectives, for instance. At the end, this set of notebooks aim to be the work which gives a comprehensive understanding on the application of BERT with semantic equivalence by adopting the case of Quora question pairs. I will leave the relevant links in the video description, and that's all for today. Have fun and see you next time.